Which test?
This test.
Define it.
Ah, no.
Where was the first
But the real test is life.
The real test?
The real test is
Oh,
life.
it's life, okay.
Which one?
That's
The
very
cereal?
interesting.
For Siri. For the game.
Well, you could use Cheerios.
Cheerios.
Cheerios have a lot more, well, I don't know. Does Cheerios one hole have more space than all the holes in life? Because life is kind of a grid. You have a great big hole in your life.
We're being philosophical.
I like your nails.
That's what's true.
Thank you.
I also have a confession to make.
Colors.
I'm a serial killer.
That's God.
I ate a whole bowl of,
When I leave stage.
shoot, I can't
Mine's
remember
Graham
what
Cracker, right? There's that big Graham.
apple,
But I work
apple, crisp?
Apple Jacks?
Apple Jacks,
Apple
Apple
Jacks.
Jacks.
The most.
What's your favorite cereal?
Cereal ever.
I do like life.
You like life?
I like life.
Fine.
Mhm.
But
What's your second
I
favorite?
think oatmeal, fresh oatmeal is probably, I like,
I didn't used to like it.
especially with raisins.
With raisins? You put some fruit in there?
It's supposed to be good for you to add fruit.
You don't like fruit?
Are raisins fruit?
No.
It's dried.
No, they're gross. Raisins aren't fruit. I don't like raisins.
It's dried grapes. Grapes are fruit. It's not like they're flour.
No.
Unless you don't consider dried fruits fruits.
You mean like the yogurt? Like the brand that's nice,
But I
they
think
dump into it.
naturally they would be considered. They should be.
Well,
Okay, so we're missing Scott, but I guess we could, we're missing Ben.
Oh,
Oh,
Ben's right here.
you're Ben. So who's the guy that usually sits over here?
There was a fifth guy over there, I think, though. Really?
But this guy is different.
Yes, that was different, right? And I think he was here earlier, wasn't he? Or am I confused? I just
Anyway,
read.
are we gonna, what's going on?
Okay, so.
Why don't we talk about
Okay, yeah, this is fucked up. Okay, so,
Are they?
so up to this point, I've been lying to you all about the nature of symbolic logic because this is an incomplete system. At the point that we talk about just P's and Q's, R's and S's and whatever, and so all the problems we just did were really the way logic books tend to present these so that you can get used to the rules. But as I said at the beginning when we started talking about the symbolic system, that these are all variables that represent A, E, I, O statements. And in fact, it could be even more complex than that. And so the system actually includes other symbols that we didn't talk about that are expanded on in the text. And that's when we get into quantification theory. Quantification theory has to recognize that the kinds of statements that we can make that are true or false can be either universal statements, where they're talking about all members of the set or no members of the set, and they can be particular statements or synthetic statements, such as some members of the set, right? At least one member of the set, right? So some. So we have to quantify in our symbolic notation how many we're talking about. And there's two ways of doing it. The universal would be to just put a variable, so X could be your variable, in parentheses, and say that that represents then for anything you pick, right? And if I'm going to have a complete statement afterwards, I might have, no, bless you. For anything, if it is S, then it is P. So that statement would represent all S as P. For example, right? If I wanted to say no S is P, I would simply use the universal, and I'd refer to it this way and say not the case. Right? So for anything you pick, if it's S, then it's not the case that it's P. Now, we have a different quantifier for the I and O statements, and what we use, and this is pretty universal, is a backward E with the variable that you're going to use, so that I can have something that is S and P. Now, notice there is an interesting difference between universals, where you'll say, if it is S, then it is P, because you're talking about all the members of the set. But when you're talking about a particular statement, you say there exists an X such that X is S and it's P. You don't want to say that if there is an X, then if it's S, then it's P, because that's not really equivalent to what we are trying to say. We're trying to say there is one, and it is both S and P. Right? So this is your equivalent for an I statement. Right? And then we have the same quantifier so there exists an X such that X is S and it's not P. And so that's our equivalent to an O statement. Right? So if you think, okay, instead of P, Q, R, S, now what I've got is all of this instead. You can imagine the symbols now are going to get, they're going to look a lot more like computer languages that you're probably familiar with. But now, the interesting thing is once we have our statements in this kind of symbolic system, before we can use many of our rules, we have to get rid of the quantifier in order to do anything. Because the quantifier here is the main operator in this entire line. So, for example, I had a situation where I wanted to use if P then Q. Sorry. Take this out of line first. So if I wanted to say if P then Q, P, therefore Q. But now what I have is for anything you pick, if it is S, then it is P. And then I have someone say, and it turns out that there is an individual S. So you think, oh, well, since there is an S, then there is a P, so I can go right to the conclusion PA. And the thing is, well, but our rules don't allow us to do that. So what I have to do first is have a new rule that enables me to get rid of all of this stuff. And so the first rule I have is called universal instantiation. Universal instantiation says whenever you have a statement that says for anything you pick, you can instantiate this, because since you're saying for anything you pick, well, then I can pick something. So I'll pick A, right? So in the case where I have if Sx, I can instantiate this. Right? Instantiate just is a fancy word that means give an instance. Right? You're saying that all S is P. Then here's A, PA. Right? So I can give an instance. If you're following in the text, you'll see that there are some specific things. You can screw this up, of course, but just basically you're you're saying, oh, okay, so I'll instantiate, that gets rid of the quantifier. So now I can play with this with my rules. So I can come back up here and I'll say, well, so SA, then PA, and I have SA, so therefore I can have PA. And I just have to say that, how did I get this? Universal instantiation on line 1. So that's the first rule, universal instantiation. Universal instantiation gets you out of a universal quantifier. If, by the way, what I needed at the end here was, so therefore, everything is PA for all x, PX, right? Which would be totally false. There's nothing that is the case for everything, although I suppose Aristotle might have said for anything that exists, it has to have substance. So that we might be able to argue that Aristotle's right about that by definition. But, so how would I get back into a universal? I would have to do that by using another rule that's called UG, or universal generalization, which enables me to put it back into a general statement. If you think about it, there are lots of cases in English. You might not think about it, and it does really get quite interesting, and you begin to realize how ambiguous a lot of what we say is. For everyone in this room is wonderful, right? That's pretty easy to say. Does it make sense, if I were to say everybody is wonderful? Now I'm talking about everybody in the whole world. There are situations where I could end up being circular. So if I'm talking about everyone here is smarter than everybody else, that doesn't make any sense, right? Because it's self-inclusive, right? So I'm saying basically that everyone here is smarter than everybody else, including themselves, which is dumb, right? But if I say everyone here is smarter than everybody else, and what I mean is everybody else besides yourself, that's okay, and you all agree. So there's all kinds of interesting things that we can learn when we start translating about that. But notice that if I'm a cop and I go into a murder scene and I see all these different signs of what has just happened, and I can start to make conclusions like you would like with CSI, right? Right. So the murderer was standing in this spot. He was obviously right-handed. He was obviously a he. He was probably about 6'2" because of how tall the murdered person was and where the knife wound entered into his, neck or whatever, right? So I can come to all sorts of hypotheses about who the murderer was, how tall they were, that they were right-handed, because normally you use your dominant hand, etc. So I can have all these characteristics. And I might even be imagining a specific individual in my head as I'm doing this. So I'm actually instantiating in this case, right? In order to figure out what these particular properties of the hypothetical murderer was, right? But I do have to be careful because I can't presume that the particular individual that I'm instantiating is actually the murderer. I can't go right out, oh, it must be so-and-so. He was the one that did it. Because he's 6'2", right-handed, hates this guy, whatever, right? And I need other evidence before I can actually identify a specific individual. So I do have to be careful and follow specific rules as I'm figuring out this, instantiating this. And so, for example, when I'm instantiating in this case, I have much more rules restricting who I can pick when I instantiate an existential statement. Because I have to be careful that whenever I do this, I exit this hypothesis by generalizing and coming back to someone. So someone murdered this person. They were probably tall and looked just like George Papadopoulos. But I can't conclude that George Papadopoulos did it. But when I make my specific conclusions, I can then say, so whoever did do it, that someone was tall, right-handed, etc. So I have to get out of it. But so I have 4 rules altogether. The first one, universal instantiation. Second one, universal generalization, to put my quantifier back. And then I have existential, so we use the regular E for this, existential instantiation and existential generalization. So those are 4 rules that we could use in order to manipulate the quantifiers so that we can continue to use our rules as we've been using them. But notice that will add some more cautionary statements, and we're trying to figure out things so that we don't accidentally presume guilt where we don't have the right evidence and so on, for example, right? Okay, but now let's look at translating into everyday speech, or from everyday speech. That's what I asked in the first section of the test. I give you some problems where I'm using symbolic logic, and you have to use the index or dictionary that I include in order to figure out what's going on, right? So here's the dictionary. Example, if you see the expression px, that means that x is a person. If I use lx, it's x is a librarian. If I see ax, that's x will earn an A in logic, etc., right? Notice if I have a 2-place predicate, it's interesting because this is something, by the way, that Aristotle did not consider. So when we get our A-E-I-O statement types, all S is P, some S is P, no S is P, some S is not P, none of those predicates are reflexive or self-referential, or in this case, so X borrowed Y. Notice we can say that, of course. Jimmy borrowed a Quine book from me, right? So a particular book I lent Jimmy, right? If I'm talking in general, someone borrowed a book from the library today. I don't know who, I don't know which book, so I can talk in general terms, right, in English, right? I don't have to know specifics, but I still know at least someone borrowed a book today. Actually, I'm sure that no one borrowed a book from the Eagle River Library today because the library was closed. But tomorrow they will. Tomorrow someone will borrow a book from the Eagle River Library. In fact, I'll go and borrow one myself just in case, just to make sure that that's a true statement. So this is a kind of predicate that Aristotle didn't talk about. And in fact, we can have multiple. So I can have X borrowed Y from Z. Right? We could do that in English. So these are interesting predicates that logicians have trouble trying to figure out, well, how does that actually fit with the idea that there are only 4 types of true or false statements? Because this could be certainly true. And there's multiple places here in these relationships. So that's another fun aspect of contemporary logic and so on. But, so, in our translation schema here, our dictionary, you have to be careful that if I have like AX, that's just X will earn an A in logic. But if I have EXY, that's X borrowed Y. Or if I have HXY, that's X studies harder than Y. Depends on however you set up your predicate in the dictionary, right? So the test questions I have are going to set you up with some traps. Now this is actually from another textbook where I got this whole list, and we won't use the whole list. I just have these 3 test questions, which you then have to translate using this dictionary, right? So if you're looking at this and you say, okay, so I have this. How do I read this? Right? There exists an X such that for all Y, if X is a person, then X studies harder than Y. Of course, all your friends talk exactly that way. So we actually haven't completely translated the schema into a real statement. So what would that person really be saying? It would say, perhaps, somebody studies harder than everybody else. By the way, that's the actual answer to that one, so if you want to write that down and then just send it to me, it makes it look like you figured it out. But do you see what's going on with this? Yeah, we've got we've expanded our symbol system to actually mimic the way we really speak, and try to really explain exactly what we're trying to say in a way that a computer can follow it. Because of course you're going to program the computer to know how to translate this. So we have to get more details. So we're talking about an existing X, right? Notice because I don't have the font, I don't have the E backwards. But it would normally be there exists an X. Okay. Some of the fonts that you'll see on this, instead of just X in parentheses, what I've seen today on a lot of text is an upside down A with the X like that and no parentheses. So you'll see lots of these. But if you think, well, wait a minute, there's only 4 different kinds of statements. Those 4, right? So if you're looking at a system that's different because of the fonts that are available to the person writing the text, you basically have just those 4, right? And 2 of them are quantifiers. The one would be the universal quantifier for the all and none statements, and the other one would be the existential quantifier. Notice we call it existential because it has existential import. Remember the Boolean problem when we look at the traditional square, we realize that, well, wait a minute, that doesn't really work in modern English because we worry about someone saying some paperbacks are more expensive. That seems to imply that there are real paperbacks. It's not an empty set. So it has existential import, means something that the universal statements do not necessarily have. That they don't actually imply existence of members of the set for some reason. I don't know why that would be. I actually disagree with this whole problem. But I'm just Joe Snuffy sitting in UAA. You know, that's not Harvard or Princeton or Yale or one of those smaller schools back east. You know. But you get the idea, right? So So there are other fonts out there, but once you're used to the idea that there are just two main logical operators that we refer to as quantifiers, one is for all and the other's for some, and then, okay, so you figured them out. It's pretty easy. So this, notice, refers to the x as the variable. So when you come over here, notice where the x variable shows up, that's quantified by this one. But where the y quantifier, where the y variable shows up, that's quantified by the y variable, right? And in fact, I can have multiple. I could have x, y. Usually that's why in the system we got up to p, q, r, s. We kind of stop with the symbols at that point because we leave the x, y, z's for the quantification. So that's kind of why those disappeared if you were looking for those. So this one, when I'm looking at how this works, I wouldn't even expect someone to utter, if so-and-so is a person. Then they borrowed y. Or they're smarter, actually this one was, they're smarter, they study harder.
They study harder, yeah.
They study harder than y. And there's some actual problems here too, because normally when you're studying harder than someone else, you think of that other person as a person too, but notice it doesn't actually say that y is a person. It just indicates that x is a person. So strictly speaking, this is kind of garbage because it's suggesting that somebody studies harder than everything. And in fact, it doesn't have the non-identity clause attached to it, which would have to be there in order to tell the computer that you're not including itself. You know, x is not identical to y. Well, in other words, someone is studying harder than everyone, including themselves. So that's really pretty dumb. You know, if you're writing computer code and you're, the swordsman is fighting against the dragon, and you tell the computer, his sword slash destroys everything, poof, and the screen is gone. Whoops, that's a mistake. You don't want that. You just want the dragon gone, not everything, right? So you have to be specific when you're typing the code, etc. Otherwise your boss says, what happened to the game? Everybody just died. Thanks. Whoops. Shouldn't have been so vague. So everybody dies. Hitler would have liked that commit, but he still thought he had a chance of winning even up to like the last day.
Kind of how insanity works.
Insanity. Just read a book about Hannah, the pilot that tried to rescue him at the last couple of days. She actually flew into Berlin to pick him up, but he refused to go. And so she flew back out. And he nicely gave her a cyanide capsule in case she wanted it. She kept it until she... Okay, so what other things are interesting about this one? So the y is universal, whereas this is particular. So it's a particular person that studies harder than everyone else. But notice, because of the laziness in the code writing here, you're not indicating that the everyone else is a person, and plus you forgot to include this, right? So, strictly speaking, this indicates that someone studies harder than everything in the universe, which is just really dumb. This one, now we have there exists a y such that for any x, x is a person, and it's not the case that x is identical to y, all this is just background knowledge, because here's the real statement right here that says X, what's L? I forget.
Librarian? I think it was librarian.
Yeah.
X is librarian.
X is a librarian, or, well,
LXY is logical though.
yeah, okay, so
X is
you have to be
logical.
careful, if it's a predicate that has two places, it could be different in the dictionary than one that just has one. So if it's just LX, then X is a librarian. But if it's LXY, then it's X is more logical than Y. So in this particular statement here, I have X is the universal, right? And is a person, so everyone is more logical than someone else, or actually something else. It doesn't say that Y has to be a person. But, so, everyone is more logical than something else. This is fun. We're just really treading quickly over an awful lot of material, but that's the 5-minute version. So C, the last example in this, there exists a Y such that for all X, X is more logical than Y, and it is not the case that Y is a librarian. Exercises like this are hilarious, right? So how would that come out in everyday speech? So Y is someone. X is more logical than Y. So everyone or everything is more logical than something that is not a librarian. Where this exercise was absolutely hilarious. It had violins, being more logical, it's just all kinds of confusing.
Can you say that again real quick?
Yeah, so if we think about it, this is the real statement here. All this stuff is like background, explaining what you're going to be saying when you're here, right? So there exists a Y such that for all X, X is more logical than Y, and it's not the case that Y is a librarian. So if I put that into English, I end up with something like, everything is more logical than something that's not a librarian. And it could even include yourself, since that is everyone. So these are just fun. But, just so you're aware, when you see logic texts, normally in, say, like a sociological essay that requires the argument to be included in a logical, symbolic logic format, usually kind of as a test to make sure that the author is worth listening to, right? This is more what you actually see instead of just P's and Q's. The P's and Q's stuff that we were dealing with in the previous set of exercises is like the shortened version of it for you to learn the rules. Oh. This next one is really quite interesting. A lot easier than it looks, I think, at first sight. In the text, I believe it's one of the rules listed in the back. and it's referred to as the quantifier exchange rule. Oh, so in this text, it's change of quantifier. It's on this page right here. And I don't know if you could see change of quantifier. See if I can find something interesting here. Oh, this is a video. That's all for them. Okay. So, notice this is the universal quantifier here. And notice he's got the existential quantifier with the backwards E. So that's kind of interesting. So you can look this up. There's lots of interesting stuff on this. But so here's how the rule works. If you're going to change a quantifier, and by the way, the philosopher that discovered that this works, as far as I know, is Willard Van Orman Quine. He decided to die December 2000. December 21st, I think, not the 20. I don't think he made it to Christmas, but so he died. He was in his 90s. But in 1952, he published an article called Two Dogmas of Empiricism, where he basically destroyed the connecting link that we've inherited from Aristotle, so over 2,350 years old belief that there are two different kinds of statements, universals versus particulars, and in fact that ended up becoming different kinds of knowledge. So we have definitional knowledge, which is associated with universal statements, all horses are animals, and we have synthetic or particular knowledge, which is associated with a specific individual. That horse is a gelding, right? So for over all this time, we thought there were two kinds of statements, and that they were quite different, and that the kind of knowledge we had associated with the one was very different than another. 1952, he destroyed that famously with his Two Dogmas of Empiricism. And here's how the rule works. If you have a universal quantifier, so for anything you pick, whatever, right? That is equivalent to the particular quantifier, the existential quantifier, provided you put a negation sign in front of it and behind it. So think, for example, how this works. For anything you pick, such and such. Isn't that the same as saying it's not the case that there is something that's not such and such? Yes? If I say, for anything you pick, it's not such and such, that's equivalent to saying that it's not the case that there is something that is such and such. If I say it's not the case that for anything you pick, it is this, that's equivalent to saying that there is something that is not that. And if I say it's not the case that for anything you pick, it's not that, that's equivalent to saying that there is one. at least one. So we have this change of quantifier rule for a statement that's a universal. You can turn it into a particular statement by just negating, putting the negation in front of the quantifier and after the quantifier. So you change the quantifier and just put, now the pattern is actually you're always putting a negation sign. Sometimes they disappear because you have double negation, right? So this, very easy. If you have this, it's equivalent to this. If you have this, it's equivalent, and vice versa. You go back and forth. So that's all that is. And by the way, that turns out to be very useful in writing code because sometimes you're going to have to go from the, if I have the negation sign out in front of the quantifier, I can't use universal instantiation to get rid of the quantifier because now the negation sign is the main operator in the line. So just getting rid of this is illegitimate, right? So what do you do in that case if you have to get rid of it? Well, you swap it for the other quantifier. Now the negation sign is gone and you can instantiate. So it's really a very easy test question. So I give you an example of a quantified statement and I say, so use the quantifier change rule or change your quantifier rule for this statement. So in this case, since I have the universal quantifier here, you would just delete the negation sign and you'd have the exist an X and then everything else is the same except you have to put the negation sign there. So if I looked at this one, it's this example here. See it?
So it would be X, because you get with negation sign. Look backwards.
But we're not gonna be able to do that right on the computer, so we're just gonna put EX. Right?
Yeah, see what you could do with your fonts. Notice I don't have a conditional statement, I just put the little arrow thing.
Saying you have the backwards E negation
Yeah,
sign.
but you could use forward Z. There is actually, if you go looking for it, the backward Z is on the QWERTY keyboard in the Windows operating system. It's on one of the other keyboards that the symbol keyboard, I think.
Do you take out negation for a Q as well?
No.
Okay, so what will change? Just
The only
take
thing
out
that changes here is you put a negation sign here, and everything else stays the same.
Then you take the negation.
Well, you gotta put an E, don't you?
Yeah, you do have to put it in.
Yeah.
Put it there.
Okay.
And so I would have,
Yeah, just write it all out so then.
yeah, I want to make sure you guys get a perfect A. Sure that
So
works.
thoughtful.
Like to be thought of as thoughtful.
Thank you. Alright,
Remember, this is a business.
And now
I
you
have
say-
to be,
We just actually pick one of those questions from this.
yeah, I just picked that one. You could pick it. You mean this one?
Yeah, number 3. You just pick
Oh,
one of
for
those.
number
You
3,
just pick one of those 3.
well, this is a short essay response to this.
Oh, gotcha.
4, select 2 of the even-numbered analogies, and I'm not sure that's in the, I'm not sure it's 492.
It's just gonna be like the
It's
first test.
493 and 494.
493 and 494?
Yeah, because the questions don't start until 493.
Thanks. Everybody hear that?
Is this gonna be like the first test where we're picking
Well,
3 or 4 out of the group, or?
you're actually doing each one.
Yeah.
Each one, okay.
But since I've given you 1 and 2, and 3 is really quite, it's an opinion question, so I'm sure your opinion will be your opinion. I'm not gonna critique you for saying your opinion is not your opinion, you made a mistake. That would be wrong. But now 5, I think, is really cool. That link still works, I've checked it, and that's still there, so you could like play with the updated Alaska budget.
Is there a minimum word count for these?
No, no.
So you want this?
You, but I'd rather you not just simply say,
And
Yes.
we're,
True.
yeah, yeah.
Yes,
That might be your
Is it due
conclusion.
next class?
Pardon?
It's due next class?
It's actually due by, I think, August 5th, but
Yeah.
next class would be good.
Alright. So,
By next class, I think they will open up the
And do you,
final, so I can put in the grades. Yes.
The analogies on 93, 94, are we just gonna use that dictionary up there?
Oh, for the analogies, it's different.
Oh,
Let's just do what we did
Yeah.
today.
Well, the analogies, you're talking about different analogical arguments. Remember we talked, did we talk about analogical arguments? Probably not, come to think of it. We will next class, though. So the things that we haven't finished with the book, we'll do next class.
Doing one is the first two.
I have to do 2.
2 and 4.
Yeah, that's what it is.
And then I do have the
No,
bonus question on here, which
I
is
did say
fun.
one.
What is the bonus question? I'm
Bonus
guessing it's that
question is-
classic question there. Theories,
It's the
proposition,
class,
is.
yes, yes.
Yeah.
This proposition is not true. Is it true or not?
True.
So if this proposition is not true, then it's false. In which case, of course,
Maybe
that's
true.
exactly what it says, so that means that it's true.
True.
Yeah.
But if it's true, then it's false.
False, so.
Well, but that's what it says it
But that's
is,
what it's
so
saying,
that
so it
it's
has to be true.
But it says it's false.
True.
True.
You want to drive yourself bonkers. This is Charles Sanders Peirce's argument on, suppose it is true.
That's
This
intense.
is not true.
Well, I thought the final line there, which is absurd. That's true, then.
And this is
so with the analogies on like the 94, where you see
Well, so the analogical arguments that they give you on the page in the exercise are oh, that's not even the right one. I'm glad you noticed that. That's why you're asking. Hmm. Yeah, it should be the analogical arguments, which is chapter 10, so that's not even the right section. In fact, I have a note in my book here that says fix problem number 4 in the final, which you notice I didn't fix. But so the page is actually 524 to 526. I shall not actually write on this one. I can't fix it. My website is inaccessible. thanks to my machine being an XP, Windows XP. So Sunday I tried to fix some stuff, and it won't let me log in. UAA has taken all the XP machines off of the network.
So they need to give you your profile back.
I have yet to address it to someone who might be able to. Remember, they took my office,
Right.
and that meant I lost a dedicated computer there. And the one that I have in on the main campus is no longer usable because it's XP. So at the moment, I have no machine that's dedicated on the UAA network computer, which I have to use in order to connect to my web server to fix my web. So I'm trying to decide, okay, so I'm supposedly retired. Maybe I should say, oh, the heck with it, and use Blackboard. I really don't want to use Blackboard. Oh my goodness, I hate Blackboard. However, it's probably good for my brain to come up with all sorts of new ways of doing things. It's been really nice and easy to just go and update this and then just say change, and everything's all right. But at the moment, it appears that they've deleted me. So the website is still there. In fact, I've got friends who been like retired for years, and their website's still there. So no one goes in and actually cleans out all this old stuff. But it's not really very useful if I can't update it for the classes. So, but all they have to do is give me a computer that's updated that I can use on the web to connect to it. Should have some. Doesn't even have to be that new. So, what we're going to do next class, and we can start now, is all the chapters that we haven't covered yet.
That sounds so fun.
Yeah, it's like this much stuff. But most of this stuff is stuff that you get in other classes too, like statistics, science courses, things of that sort. So it's not really among the more important things for the logic course. We've covered the things that the logic course is required to cover. But the texts usually cover other things, like inductive reasoning, analogies, things of that sort. So, probability. There are rules for probability, but they're only probable. So if you go to Las Vegas and you play the games based on the rules that you get here, and you don't win, it is not my fault. But as a matter of fact, every time I go to Las Vegas, I win.
You do?
Are you?
Pardon?
That's what it is.
Well, what I do is I go in and, when you check in, they give you a $25 card, which you could use to get started. And they're assuming that as soon as you run out of money that they freely gave you, you're addicted already to the game and you'll just keep playing. And then you'll start using your own money. What I do is I use the card until you get down to like around $5, and then I cash it out. So I always leave with $5 that I didn't have when I went in. And actually the main reason I go to the casinos is for the cheap food and the art.
Is it cheap food?
It's really, really cheap food.
Yeah,
Because I feel like
for Vegas, it's
I'll show you how cheap it is.
just I think the diner is the word. freaking expensive.
Yeah, it's,
Like,
you can
like
use
$5
garbage.
plate, you spend more money on it. Some of the
Yeah,
nicer
they
things.
want you to stay in the casino.
There's also like all the
You
fancy
would
ones.
have basing all this off of regulations and then
But you can feel it's warm.
Yeah, you can
Feel it, like in my living room slash kitchen room, like, it's so right on. You just feel hootered every. Yeah, I'm really happy that it's only been around this because I'm this close to it.
It's not my business.
My problem is they start bringing the dreams and stuff, it's like, ah, it's
It's already almost August.
What are we watching?
Aha.
Emma at the casino.
So this is at Caesar's Palace,
Oh my Lord, have mercy.
and there's just 3 of us, and that's how many lobsters they gave us.
For how much?
For the, it's like, you pay per person, it
How much was it per person?
was like 20-something, total 20-something.
Per person?
For the whole, all 3 of us. And I tried to figure out, geez, what kind of a tip should I give these people? Because they gave us a family serving of lobsters, plus the mussels, plus all the bread and everything else.
I haven't eaten all day, this is not good.
Yeah.
We had to take most of that
This ain't
home. We
cool.
took most of that home because there were just 3 of us.
No. Okay, I'm gonna have to leave now.
yeah.
And the reason we got lobster was because we had grandmom and grandmom
Hello,
can't
welcome
eat.
to another exclusive review with me, Alex Belfield here
What's
at
it called?
Celebrity
Stuff that
Radio
you get
Dolphins,
from
where
Red
last year we had over 8.3 million minutes viewed on YouTube. This week we focus
the shines, this water,
Is it like a card or something?
Let's see the art.
Just a fact.
hard, but we could also just get things to go.
Thank you.
Place right.
Everybody has an A for test 3.
And the final.
And the final, right?
Backflips out of the classroom.
Because I actually have to turn in the grades based on what I really have. And I actually am honest.
So you want me to do something now, or just like to get the
Oh, yeah. Did you get a chance to see what the test was? You missed it.
I wrote the box.
No problem. Well, you can give it to me next time.
I mean,
This
Can we
is
go
the
back to
tune,
the
I
final
guess.
ones of questions?
The fountain. And I know we're near where they have the,
Okay, so, scroll up, okay, that's fine. So, can you come in on there, I wanna show you this, stuff down. So, when you translate these, cause you want us to translate these, this one was, you said was translated to someone studies photo than everything.
mm-hmm.
And then this one you said was everyone is more logical than something else.
Over?
It should actually be everything is, yes, that's right. Something else.
So there's everyone is more logical than
Than
something else. Okay. And this one
Else
was,
is spelled,
I know, I'm not collecting
Oh.
when I actually write it down when I do the final. I was just writing it down so that way it is. And then C was everything is more logical than something that is not a
than
librarian.
librarian.
Okay, so yeah, I did write these down right then.
Yeah, but you have Liberian there.
I know, I'll collect it when
I didn't have any ethnic issues
Oh.
there.
Well, I'll
Librarians are,
collect it when I do it.
anybody could be a librarian.
But, and then this was this, because you just take this
Yeah,
off
this-
and add one
Right,
deal.
right,
So
right.
then it would
Mhm.
be this, correct?
Yep.
Cause I'm just gonna put the E here, cause I don't have the backwards E on my laptop. And then my other question, final question, and can you scroll down to those questions? Down more.
Yeah, so this isn't 492, 494.
Yeah, I only
That's
wrote
actually
that
the
down.
whole next chapter.
I wrote that down, so, can you scroll down now? Okay, so, another question, can you come on that? My final question is for this one, the bonus question, you were saying that it's true, right? Because you said that this is true?
Well, the question is,
This
this proposition is not true.
Okay,
And so the question is it true or not?
and you said it's true. Oh,
Well, I'm
it's not
asking,
true.
is it true? I didn't answer.
Oh, okay. I thought you said that was true. Okay.
Well, if it is true,
Classes this summer?
In the fall. we
Then
take,
it's false.
Behavior analysis, psychology, so.
right,
Are
because
you
it
saying
says
it's
this
true?
proposition
yet,
is
but I
not
plan to
true.
be.
Yeah.
So if the statement is true, it must be false.
Okay. So it's false.
I got my degree in philosophy.
Well, then
But you
it's
did.
true,
Yeah, 2013.
because it says it's false.
And in order to do that, I had
So
to pass
then
his
it's
logic
true.
class.
It must have been harder.
Which
on
means
you
then
than
it's
it was
false.
on everyone else, right?
I guess
So is it true or false then?
Are you gonna,
That's the
so
question.
are you going to?
So it's true
be a
then.
psychiatrist or what?
Well, it's
I'm
false.
hoping to
If
get
it's true, it's false. If
counseling,
it's false, then it's
psychology,
true.
Therapy and stuff.
Yeah.
Yeah.
So what does this guy say about this? Cause I
Oh.
wanna know if this
Oh.
is true or not,
Oh.
cause now you're like confusing me, it's driving me
Well,
crazy.
it's not just confusing you, it's confusing everybody.
Thank you, have a good night.
Good night. Where did it go? Oh, shoot.
I think it was down.
It's actually, down right. There we go.
It's tabbed to a specific spot in the.
Oh, yeah,
Yeah.
so the proposition is not true, which is a bonus question, so therefore it is true.
Well, suppose it is true. Then the proposition is true. But that it is not true is the proposition. Therefore, ergo is therefore. That it is not true is true. So therefore, it is not true. Besides, it is true. It is true that it is true. It is not true that it is not true. But the proposition is that it is not true. Therefore, the proposition is not true. Therefore, whether it is true or not, it is both true and not. Therefore, it is both true and not, which is absurd.
So what is it then? Hold on, I'll take a picture of that.
You have to admit, for your bonus question in your logic course, that's gotta be just about the best possible question.
So then, it's both true and not true.
Exactly. Which is, that's impossible, it's absurd.
So, would you